Have you ever wondered how distributed systems keep data consistent, even when it's spread across dozens or even hundreds of machines? In systems that use consistent hashing, like Dynamo or Cassandra, achieving strong consistency isn't automatic. But there's a clever mathematical trick that brings us close: the formula R plus W n har. Let me break that down. When you store data across multiple replicas, you define n as the total number of replicas for each key, W as the number of replicas that must acknowledge a write, R as the number of replicas that must respond to a read. Now here's the magic. If R plus W is greater than n star, then you guarantee that at least one replica involved in the write will also be involved in the read. That overlap ensures that you never read stale data as long as there's no failure or delay. Let's take an example. Suppose you have n equals 3. If you write to W equals 2 replicas and read from R equals 2, then R plus W equals 4, which is greater than 3. That means your read will always intersect with the latest write. It's not full-blown linearizability, but it's a powerful way to approximate strong consistency in a distributed, eventually consistent world. But there's a trade-off. The more replicas you wait on, the slower your reads and writes become. If you set W equals n har and R equals n star, you'll get the strongest possible consistency, but also the highest latency. That's why systems like Dynamo let you tune these values based on your priorities: speed, availability, or consistency. Now, if you want true linearizable consistency, consistent hashing alone isn't enough. You'll need a leader-based protocol like Paxos or Raft, or route all operations through a single replica. But in most real-world scenarios, R plus W gets you a sweet spot: consistency without sacrificing performance. So next time you're designing a distributed system and someone says consistent hashing isn't consistent, tell them it is, if you know the formula.